We use implicit differentiation if we have a function that if we try to make one of the variables the subject of the formula, it is complicated or it can be impossible. That is when we use implicit differentiation. If we have this function y cubed plus x squared y to the power 4 plus x cubed y equals to 9, and we are required to find dy dx. In this case, we cannot make y subject of the formula, or it is quite complicated or tedious to make y subject of the formula. We have to use implicit differentiation. So this is the hint. When you are required to find dy dx and you cannot make y subject of the formula, then you have to use implicit differentiation. The word implicit is the opposite of explicit. In other words, if you cannot express this function as explicitly as y being equals to something else, if you cannot do that, then you have to use implicit differentiation, like in this case. So I'm going to explain how you do it using this as an example. I'm going to rewrite my equation and then go step by step explaining what you have to do here. We have y cubed plus x squared y to the power of 4 plus x cubed y equals to 9. As usual, when you are doing differentiation, it is a matter of differentiating each term. We are applying here several rules because we are going to apply the sum and difference rule. We're also going to apply the product rule here because we have a product. We apply the product rule here. Here we are differentiating a constant. Here we are differentiating y cubed. That's all. So I'm going to differentiate each and show you what you do. Okay, the first one, y cubed. We are differentiating this in terms of x. So we differentiate it as it is to be 3y squared. We multiply it by dy dx. So every time you differentiate y being to the power of something, you have to multiply it by dy dx because we are differentiating here in terms of x. Then I go to the second term. It is a product. I'm going to start by differentiating x squared. If I differentiate x squared, I get 2x. I multiply by y to the power of 4 plus, then I'm going to differentiate y to the power of 4. So I keep my x squared. I differentiate y to the power of 4, which is I'll be multiplying here by 4y cubed. But because I'm differentiating y to the power of 4 in terms of x, I multiply by dy dx plus, I'm going to go down here, x cubed y. It is also a function of, it is also a product. So I'm going to apply the product rule. I'll differentiate x cubed first. I get plus 3x squared times y plus, I keep my x cubed. I differentiate y, I get a 1. But because I'm differentiating y in terms of x, I multiply this by dy dx equals to 0. I also differentiated 9, so I get a 0. The key here is to remember that every time you differentiating something, a power of y, you have to differentiate it and then multiply by dy dx. That's it. Now from here, once you have this function here, you now have to work on making dy dx subject of the formula. So you have to use your algebraic skills, your skills of algebra, to make dy dx subject of the formula. Once you do that, you are done. So let us put together all the terms that have dy dx. I'm going to leave them on the left hand side. So I'm going to mark them. This term here, we leave it on the left hand side, and this term on the left hand side, and this term on the left hand side. In other words, I'm putting together all the terms that have dy dx. Then this term and this term, I'm going to shift them to the right hand side. So they're going to move to the right hand side. Let me clear part of the board to illustrate this. I'm going to clear this. Okay. All right. So I'm going to rewrite this function. So it is now 3y squared dy dx plus x squared 4y cubed. So it will be 4 x squared y cubed dy dx plus this one here is x cubed dy dx, x cubed dy dx equals 2. Now this one is going to the left hand side. It is positive here, it's going to be minus, so it is minus 2x y to the power of 4. This is also going to the left hand side, so it's going to be minus to the right hand side. I mean, it is going to be negative 3x squared y, so 3x squared y. I am rearranging, or in other words, I have just rearranged. Okay, I'm going to clear this board. Now I have rearranged like terms together. In other words, everything that is having dy dx, I'm putting them together. Everything else I'm putting to the other side. Now I can, because dy dx is here, it is here, it is there, I can now factorize it. I can factor it out. So we're taking out dy dx. So dy x bracket 3y squared plus 4x squared y cubed, so this is squared, plus x cubed, close the bracket, this is equals to minus 2xy to the power of 4 minus 3x squared y. Now to completely isolate dy dx, I have to divide both sides by 3y squared by this. I have to divide both sides by this so that I can isolate my dy dx. Therefore, dy dx is equals to minus 2x y to the power of 4 minus 3x squared y all over 3y squared plus 4x squared y cubed plus x cubed. This is the final answer. We have used implicit differentiation. All we have to do is to be able to differentiate each term, bearing in mind that whenever you are differentiating a power of y, you apply the usual rules, but you multiply it by dy dx. Then to finish off the question, you have to make dy dx subject of the formula. Otherwise, everything else is straightforward. Just get the hints. If you have a function in which the x's and the y's are mixed together, and you cannot make y or even x explicitly as the subject of the formula, if you cannot do that, or if it is complicated to do that, you use implicit differentiation. That is the hint. Otherwise, that's it. If you have any question or you need clarity on anything, or if you notice a mistake that I would have done, just notify me in the comments below. I will look into it and respond to you. Otherwise, thanks for watching the video. subscribe to the channel and give the video a thumbs up.